Hello, welcome everyone. I'm very glad to be in DConf again and have another chance at talking some stuff to you. And yeah, my name is Mihails and I'm here on behalf of the Semantic Labs, the very company mentioned in the subtitle. So I must admit, after taking a transatlantic flight, statement about being not so far away doesn't feel that legit anymore, but at least in the same galaxy. And yeah, I'm going to talk about some experience we had about finally switching our code to D2, what happened. But first, some explanations for those who haven't really heard much about our company, what we are doing, stuff like that, which is totally forgivable. So Semantic Labs is relatively old to user, so it's kind of startup founded in 2009, and it's all about real-time bidding, online advertising domain, which is actually very interesting thing in a sense that it was a certain revolution in the online advertising market that no one has noticed, and it just works as expected for all the users. And then you go to the Wikipedia, for example, via the URL I have provided in the slides, and start reading that actually every time you visit some web page, a real-time auction happens, and a bunch of some weird guys make bids personally for your personal ad space, and it will happen in some 50 milliseconds. Then you're like, oh, and this stuff was happening for the last 5 years, and I have noticed that. And then your mind sometimes gets blown. So yeah, if you're interested, those are the links. Also, my colleague, Don Claxton, gave an awesome talk with a bit more details about our company, what we do and how we do during last DConf. So if you haven't seen that, it's also mentioned there. And yeah, there is one unfortunate fact that I was ashamed of, is that all this time we have been still using the one version of the programming language. And it has been bothering a lot, at least me personally. But relatively recently, it has all changed. And this is exactly what I'm going to talk about, at least in the first half of the talk. So this is the agenda, pretty much. I'll talk a bit about how did we port, what issues we had, how we solved them, how the process is going. And then I'm going to have a step back and evaluate various changes that happened between D1 and D2 and try to analyze a bit in how much impact they had on the transition process, and move from there on actual modern D2 times, and try to use that experience on providing some suggestions and ideas on how we could possibly handle that stuff better in the future. So, the D1 to D2 migration process. It was a very long and hard story because talks about possible migration has been happening in our company for a very long time. It was all discussed, various concerns has been raised. It was known that it will be hard. So mostly so the challenges we had is that we have quite a lot of code by now, and it's all changing all the time. It's all the moving target, including the all the base libraries. It's still being changed, and we can't really afford to stop it at any moment. So whatever porting happens, it must happen completely in parallel with normal daily development. And the amount of code says that we also couldn't really maintain two versions of libraries and applications, one for D1 and other for D2, and just backport any sort of changes, because as the time goes, we would risk getting into a situation where just maintaining already ported libraries would leave no time for moving porting forward. So that was also considered not working approach. And yet also the way development team worked, at least when the porting has started, we didn't have like many developers proficient in D2. So we tried to kind of reduce that like informational noise and stress on majority of the team as much as possible. And the last, but probably the biggest concern, is that just porting itself wasn't enough to have a confidence that stuff works as expected, because quite a large amount of our services are real-time, so they have hard requirements on how they should behave in runtime, and we can't be sure about that without some like real profiling, testing in circumstances similar to like production usage. So just getting to the state the project compiles and seems to pass test wasn't enough to be confident that, okay, that's a nice version, we're ready to switch to it. And thus kind of the sum of requirement is that all this stuff must happen in parallel. It shouldn't interfere with any normal development. And for all those like fragile real-time services, we need to be able to roll back to the one runtime and compiler at any moment as any issue gets suddenly discovered, like at any time. So during like initial research, the observations were made that kind of started the whole porting process, is that actual like fundamental changes aren't that much between 1 and 2. So some changes in the 2 are simply like making code more strict, so stuff that was like warning in the 1 world. Some stuff has serious semantic differences, but those can be hidden behind wrapper functions or templates. And after you do all of that, only very few changes remain that can be easily automated. So the first stage, which is kind of snippet, is shown in the second below part of the slide, is exactly the example of like the very first changes we started to do in our code, which is just running through the D1 code and changing it in a way that it becomes more D2 compatible. So just fixing all the stuff that doesn't compile in D2, but can also be written without any major changes in D1 to keep compiling. And for that, we added special like diagnostic flags to D1 compiler, which was a courtesy of Walter Bright. Thanks a lot for helping us with that. Which specifically kind of had a list of such like corner case, like grammar changes, small semantical differences, and provided like nice diagnostics with suggestions on how to rewrite each specific case, so the developer doing the migration wouldn't need to like think much about what needs to be done and just like evaluate the suggestion, check that it's actually like good one, and comply. That was like the very first easiest step. Then the special transition model was added. It's present in our fork of Tango, which is used as standard library in D1. And it was a special model that was supposed to hold all the differences between D1 and D2 behind some sort of like wrappers or functions. And the idea is that we don't want version blocks between D1 and D2 in majority of our code. Like, it's just too hard to maintain. It's unrealistic. Instead, it's all should be hidden behind a kind of wrappers, which provide the same semantics for both worlds, and just do the versioning internally. So this is the example of one such helper. It's kind of our implementation of typedef. It's simply a template which gets it's a mixing template. It's a template that generates a string mixin, and internally it simply generates a struct with an ls this value member and the old school typedef in D1 world, which works pretty much the same in practice. And then all the rest code is just changed to use this kind of helper instead of actual typedef. And you get pretty much the code, which is both D1 and D2 legal code at the same time. And there are probably something like 2 dozens different utilities like that, which encapsulate various stuff. So another example of utilities from Transition D is stuff to deal with const. Const probably was the worst, most effort-consuming thing to deal with during the migration, simply because there are no semantics like that present in D1 at all, but there is like const keyword which does something completely different, and it's also transitive, so you can do it like in smaller portions. Once you start adding that stuff, it needs to be added everywhere, and we still kind of wanted to get to that state where it's kind of both D1 and D2 legal code at the same time. So the idea was, why do you need to have like language qualifiers when you have templates? And yeah, so the const template appeared as also a bunch of aliases for most frequently used types like strings. And it works, like it works so far. It's a bit effort consuming in the sense that you need to work with all the code, just try compiling with the D2 compiler, add those like const templates, then go back, try compiling the same stuff with one compiler, ensure that nothing has been broken, and repeat this cycle for many times before it actually gets to the good point. So example of complications is pretty much explained here. Originally once we just did it with the simple functions, it felt all good. But then we came to templates, and for example, Tango uses templates for like string functions and stuff like that, simply so that they can handle like both char, ychar, and dchar strings. And just naive adding of const, like as if you did in D2, like as if it was a qualifier, of course doesn't work, because compiler type infers doesn't work that way. To infer the type of const t, it would need to know the type of t first, and so it creates a cycle which at least D1 compiler is not able to resolve. D2 compiler is a bit smart in that regard, but still not magical enough to just take care of that. So all those templates would need to be written like in very weird fashion, as you may see, and that was one of most unpleasant parts of like adjusting the code to that intermediate stage. Fortunately, there aren't many functions like that, so the effort was very contained, and more high-level code becomes free of any concerns about that. And the last part, so it was inspired by the defix, which Brian has presented yesterday, and also all the tooling, which really good stuff, which we use and plan to use even more in future for various needs. So the idea was that after all those initial changes, all those like fix up of all warnings and stuff, what we get is actually a valid D2 grammar, even if it is D1 code. So we can use all those goodies from Brian to implement automatic conversion for remaining stuff. And we probably could do the same approach for more of conversion rules, but the idea was simple. We want to only convert like most simple and most annoying cases and not invest much in it, because the difference in code is so substantial that we want to review all the code manually anyway. And for less common and easier to fix manually cases, it doesn't give much. So this specific automated conversion tool only takes care of two cases: converting manifold constants and adjusting this member instructs, which is a different thing between the 1 and 2. It was a pointer in one and kind of value type in other one. After all those stages, you kind of get to the point where you have a D1 code, which you can at any moment run the fix tool and get absolutely valid D2 code, which will compile. Still, of course, not enough, because there are runtime differences, and this is probably the most annoying one in that regard, is that at some point, I think actually like initially D2 behaved the same as D1, and it was like changed at some point in D2 later. The stomping prevention protection was added, which means if you have a slice from some array and you change the length of the slice, reduce it, and then try to append it, it will allocate completely a new array to prevent overwriting the original buffer, which is perfectly reasonable idea. It's a safe approach that ensures that you kind of don't corrupt your data, but there was one unfortunate coincidence, is that we relied heavily on that feature to actually reuse the same buffers and avoid like triggering more garbage collector usage. So if kind of the new runtime behavior would be adopted with the same code, it would most likely just result in generating much more garbage with the garbage collector and increase in collection cycles, and all the runtime, real-time guarantees would be destroyed like silently, and it's pretty much impossible to debug. Kind of worst kind of fear regarding the porting process. So what I did for that is pretty much like fork a runtime on my development box, put a hard assertion on cases when stomping prevention happens to just like crash the application, and then go through the cases which trigger that and add that funny helper which is called enable stomping and assumes safe append in D2 version, even if it's not really safe append, but we don't care, and does nothing in the one world. But this is kind of the last stage. Actually, kind of there are more small details like that. For example, there are some very subtle RTTI type info differences between the 1 and the 2 runtime, which also like manifested in very surprising fashions. So it took quite some time to debug, but yeah. Last but not least, so the garbage collector. So as some of you know, we have our own concurrent garbage collector implemented by Leandro Lucarella, which uses forking to kind of add more parallelization and concurrency to the collection process, marking collection. So kind of I did proof of concept port of our garbage collector, which is still available somewhere online. It kind of worked, and kind of it worked good enough to start the porting process, because that's kind of was another one of our fears. Would we actually be able to achieve that kind of like latency requirements? It kind of seemed to work, but the thing is, it's still based on the very old like 10 garbage collector, which existed, kind of wasn't really changed since the split between like D1 and D2. And there has been a lot of good stuff, good changes done to garbage collector in D2 runtime, especially all the improvements Martin Oak did in a last release, and sadly he wasn't here to tell about those, but he mentioned them during one of Berlin D meetups, and I was very impressed. So it would really like instead in future to try pretty much like re-implementing the same concurrency approach on top of existing D2 garbage collector to get like both concurrency and actually like better throughput newer garbage collector gives. But that's kind of very long-term speculative topic, because when it comes to profiling like real-time performance latency stuff, you can't really trust any synthetic benchmarks. So we are not going to put any real effort into that until we have like at least one real-time application ported, so that we can get that experimental new garbage collector port and get more real benchmarks from like real application. So that's the plan right now. But yeah, that's kind of the last and probably hardest concern about doing all the process. So to sum up all the stuff that happens, we pretty much separate all the porting process like in 3 formal stages, simply so that it will be easier to explain to each of us like what happens with each ported application. So stage 1 is kind of the most simple part that can be done exclusively while staying within the D1 toolchain. You don't need like to compile or anything special. It's all about just running V2 diagnostics flag with the D1 compiler and kind of fixing all the warnings that's shown there. After that, the next and kind of probably the most effort-consuming stage when it comes to like actually like writing code is a very repetitive cycle of trying to run D1 to fix, then trying to compile the code with DMD2, seeing why it fails, trying to fix stuff, reverting the changes from the to fix, kind of trying to fix them in D1 world and repeating again. And yeah, that can take quite a lot of time. But kind of sadly, this part it is most effort consuming, and at the same time it can't really be automated because of all the cosmos changes, which are to blame for the most effort, but you can't really automatically convert like D1 code to D2 cons correct code because there are like no clear connections between those, and sometimes it's clearly impossible without changing, like completely changing KPIs on D1 side. So that's why it pretty much has to be done all manually. And the last, stage 3, is kind of doing the cleanup. It means that all this kind of porting process and checking that both D1 and D2 compiler can work with like ported library application. So let's get added to regression control, to the continuous integration job. We use Jenkins for that. And after that, it pretty much ensures that whoever creates like new pull requests still keeps the D2 compatibility working. It won't break. And yeah, kind of even our core libraries get developed a lot and are fast-moving targets. So it was really important, and kind of otherwise it would quickly kind of become non-working stuff again. So, and the last thing on stage 3, which is not really mentioned because it's supposedly infinite work required, is all sorts of runtime profiling, fixing like all the latency issues and stuff. So it's kind of the important property that after stage 3 is done, all the downstream applications that depend on your application or library can do all the porting process without waiting until you finalize all the runtime bits. And for those who want to know more details, I have recently written a bunch of articles that got published on our like social semantic blog, which explains all the techniques and stuff used in greater details. So if anyone is interested, kind of welcome to visit the link and read more. As for now, I think that should be enough. Kind of, it wouldn't bother you with more details. And if anyone has any questions to ask regarding exactly the porting process, it's probably the best time, because I'm going to change the topic a bit and drink this delicious juice while you're thinking about equations.
one time nobody has a question, right?
All right, Steve.
Since you already have a custom runtime that you're going to have for the GC anyways, would it make sense to, instead of doing the assume safe append, to just fix the array runtime?
The thing is, this custom runtime it's on on my development machine, which I use exactly for porting. Like, we don't want to use runtime fork like for production.
But you're still going to need it for the GC, right?
No, not really. Kind of when we need it, we are going to commit it upstream.
Okay.
So
you could just say, well, if it's stuck.
Yeah, of course. But the goal is to not get separated from the upstream as much as possible, because we have been separated from D2 upstream for quite a long time, and it feels bad. So we would like to have less of that stuff and kind of try to use as much of vanilla upstream to kind of feature runtime as possible. So that's why it's kind of fix it in the source code instead of runtime. Okay, thank you. Okay. Oh, one more question. Yes.
Did you find any bugs when going to D2, like const correctness? Or?
Kind of. I think we found one codegen bug, but that was not directly related to D2 porting. It just was something that accidentally got triggered. And also, I found certain issues exactly with D2 runtime and the way how arrays are handled. There are some issues in Bugzilla, I think, about that.
I meant in your code, did you find
in our own code? Kind of, yes. I mean,
sure.
it's a bit hard to say exactly, because right now, kind of at this stage, only libraries, and not all libraries are ported. So it's all the all the stuff was about kind of unit tests, and it's still sometimes not clear if the found issues was about unit tests being wrong or about ported code being wrong. But mostly it's all related regarding possibilities, which kind of was written. Tango, in the one ages, was written in a way that didn't care about constants at all. So I kept finding cases when you could possibly override the string literals, for example, by accidentally passing them through functions or storing somewhere, because kind of there were functions, for example, which treated their argument as mutable or immutable depending on runtime condition. So they sometimes thought that it's a string literal, but sometimes they tried to write to it. And yeah, of course there were cases where kind of it went bad. Okay, so, but kind of while working on that stuff, it kind of became very clear to me that there are actually very different transition from the 1 to 2 aggregates a lot of kind of different changes, a lot of breaking changes, but those all weren't kind of the similar. So after kind of a bit thinking about that and having a look at all stuff we had to change, I separated them all in 3 tiers. So the best kind of changes we had to do was exactly pretty much all the stage 1 stuff. It's a breaking change that's really pleasant to work with. You get a nice straightforward deprecation message or warning message. It's always very obvious what you need to do to fix the thing, because the warning suggests you what needs to be done. It's not immediate breakage. You kind of have that code continues to work. You just get that annoying message that reminds you that it needs to be fixed, and no real fundamental change in semantics happened. So this stuff was really kind of incredibly easy to adjust to. Then bad kind of changes. So it's exactly const stuff. Why it was kind of one of the reasons why it was so complicated to fix all the const stuff is that it's hard to get decent diagnostics with that. You have that const feature on D1, and it means one thing. And then immediately you get the same feature in D2 that means totally different thing, but you kind of, when you have the code that still uses it in the old meaning, you get very unhelpful error messages, like in this case, you have an object stored with a const storage class, and then which is kind of legal D1 code and legal D2 code. But when you try actually compiling that with D2, you will get an error message in some place like later, like in totally different part of the code, which just says that you can't call mutable method with a const object. And you're like, okay, I probably guess what is the issue, but kind of how should I quickly find the original place of the failure happened? Even worse, there are no, like, even if you know where the problem is, there are like no exact one-to-one replacement for old semantics, so kind of that head const storage class cost, which was pretty much the only thing you can do is to try hiding the value behind the kind of getter function, so that you kind of can access it but can't modify that. But that's also breaks when you have like structs returned from such getters, so it's kind of, there is no 100% reliable one-to-one replacement for that kind of semantics, and so you always need to invent something as a replacement. In our case, we pretty much chosen to just like abandon the const storage class and remove it everywhere, so that we just don't need to care about it. And yeah, kind of the transitivity. It means that once it breaks everywhere. You can just like fix one small place, and you're committed to changing a lot of code to adjust. So this is example of a bad breaking change. At least without like any additional tools, any additional like helpers. And then there is ugly, which is exactly all the runtime stuff. It is exactly ugly because it is not as bad initially when you look at it. Like, you don't need anything special to migrate, so it seems legit. But then when you actually work with that, it becomes even worse than bad, because all the changes manifest only as runtime, and sometimes they don't even manifest as test failures or like any observable differences in program behavior. All you get is a very silent performance degradation from that kind of runtime change, and kind of without some very serious profiling tools, you can't even realistically track that down, all those like specific cases where the change in semantic has happened. And yeah, and those kind of like ugly runtime changes create very weird primary suspect effect whenever you get like any sort of like performance degradation, you every time blame that suspected semantic change for that, even the actual issue may be something totally different. So some talk, Don has proposed to use the return on investment, a term, as a way to kind of justify any sort of language, library changes, whatever. And the way it got used, but the way it got used was mostly from the language developer point of view, which means the investment means how hard it is to implement, maintain the compiler, how much does it complicate the language, does that feature actually like pull its own weight. But there is also the same kind of measure that shows how justified the change can be considered by the end user, because they have like a different investment, how much effort it takes to upgrade existing code, how much disruption in all the development it takes, and you actually can, like, you can really improve the ROI metric for the first case, because it's just about the language feature, but in the last case, from the language user point of view, you can actually improve the justification for any sort of change simply by making the effort required to upgrade to it much less, which naturally brings us to the famous "Please break my code" hashtag, which was quite a hot discussion topic in news groups for quite a while, and it keeps happening. So we kind of have a very mixed position. It can look self-contradictory from the outside opinion, that we both ask to not break things and ask to break things at the same time. And I'll try to explain it a bit more here. So, semantic stance on breaking changes is that those are necessary. Technical depth becomes more and more costly with increased team size, increased project size. At some point, you simply find yourself explaining the same annoying historical issues to new developers over and over again, and kind of its accumulated cost. Even small changes in that regard can be and often are justified if they really improve something. Even those are nitpick changes, but if they do improve something and they don't cause that kind of bad sort of disruption, it's all good from our point of view. We actually do change a lot of stuff in our own libraries all the time just for the sake of improving the learning curve and clarity of the APIs and stuff like that. And actually, you can't afford to be stable in the moving industry, so we need to keep deploying new features, new changes to our live systems all the time with no delays. And if at some point you accumulate enough technical depth that you can't actually implement a new feature reasonably fast anymore, you got a problem. So it's better to be slightly unstable all the time than suffer by surprise. And the last point, which is very non-technical, but sometimes it makes sense to change stuff, even if it's totally unjustified and makes no technical sense, simply to make people happy. Because unhappy developers write unhappy applications, and you don't want to use unhappy applications. So that's kind of purely social, organizational. But that's actually how it works. Kind of, if you get people in your team a note about something over and over again, okay, probably their concern is not justified. They're wrong, whatever. But if they know that it will remain like that for ages, it will never be changed, they will get depressed, and we don't want developers to get depressed. So, but the important part is that process matters. It's not, most often, it's not what kind of a language or library change you want to make matters, it's how are you going to do that change. And most importantly, the deprecations matter a lot. So we generally are very displeased whenever something breaks immediately. But whenever there is a reasonable deprecation path, early warning, change whatever you want. It's all good. The reason why deprecation matters so much is that we have all sorts of microservice architecture with a lot of shared libraries, dependencies between those applications, and you get, if something breaks immediately, you get into the state where you can't really upgrade to recent compiler, for example, until all your dependencies upgrade too, because there is no intermediate stage. And this pretty much applies to open source ecosystem too. I actually personally experience this time to time whenever something breaks in the MD release, when trying to work with published open source projects, that you try to use something, but it doesn't compile anymore, so you need to bother the original maintainer to fix the stuff, and he's busy, he doesn't want to do that. With proper deprecation paths, it's all good because it gives much more time window, a much better time window for update. And what's more importantly, this is the algorithm for deciding if you can immediately break the code of the bug fix or not. Right now, there is quite dominating attitude that bug fixes don't need deprecations. Unfortunately, it doesn't work that way, at least for us, because most of bug fixes aren't actually any sort of critical. So, for example, one of such critical changes in 2.67 was prohibiting redundant postfix qualifiers so that you can't write const. Okay, like, it's a totally legitimate bug fix. It was totally worth to do that, like, no objection, but was it really that much of an issue that all code would need to be like immediately issued compile error and had no time to adjust, so kind of stop working on everything else and just like remove those codes? Probably not. It was a perfectly working, valid code, even if it was like bad style. And for cases like that, deprecation process is still like very desired. However, there are of course cases when like code gain bug or something like undefined behavior gets wrongly accepted. Then you see that stuff in the changelog and you're like all panic. Crap, I hope we don't trigger that behavior in the production. I'll better call their alarm and check everything. Yeah, then it's perfectly justified to break stuff immediately. One relevant, so kind of now I'm going to speculate a bit about exactly various ways, kind of approaches you can take to reduce that kind of effort required to upgrade from the users so that any sort of changes become more easier to adjust and easier to make. So one thing is that DMD versioning is it's a liar, to be honest. I mean, there is kind of like semantic versioning, which is wide known, somewhere, which features like 3 version numbers, major, minor, and patch. And important thing here is that every time you make any sort of incompatible API changes, you are supposed to increase the major version number. And minor version number is increased only when you make backwards compatible changes. And it's not probably a standard, but it's widespread enough to the point that whenever like a random person out there sees a version number that looks like somewhere, he subconsciously assumes that it provides like same guarantees as a somewhere. And DMD doesn't work that way at all. It looks to have a major version number, but in fact, it's always just increases the minor version number, and the minor version number has all sorts of backwards incompatible changes pretty much every single release. So it is in fact a major version number, and the first one is simply unused. That's kind of just making like a better versioning and clearly separating like versions which break stuff from versions that don't break stuff could already be a huge improvement in justifying any sort of changing language or library. Another annoying thing is that, okay, when we break something, we almost never have a decent migration instructions published. We have a changelog, kind of, but it's just that, changelog stuff that accumulates all the issues from Bugzilla that was closed. Like, now it's good in the sense that it explains new features added with all the examples and nice stuff, but it never like mentions with a clear list what stuff is supposed to break and what you need to do in that case. And that alone would like reduce the effort required to do the upgrades a lot. So this is what we do for our internal libraries. They break stuff every single release, but the first thing you see reading the changelog there is the clear list. Okay, this stuff gets broken, do that and that. And that reduces the amount of effort required to do upgrades. Then, of course, like the perfect silver bullet. Something like that would possibly enable all sorts of like improvements, cleanup in the language and all stuff is kind of defix in its imaginary future form. kind of right now it's cute, but limited quite a lot in the sense that it only operates on a lexer and a bit on a parser level. So I tried to work with it a bit. Actually tried to implement an automatic upgrade tool for like our own internal needs based on the fix. And at that time, unfortunately, it didn't work that well because something as common and frequently needed as just like a simple symbol renaming is actually incredibly hard to do in deep programming language because you need to care about imports, scopes, qualification of names, templates, all stuff like that. And for that, you need at least some basic semantic analysis. So this isn't something that pure like Lexer-based tool can do. Now, kind of Brian has mentioned that he's going to separate semantical bits from DCD and kind of empower the fix with that. And I'm looking forward to it with a great hope. It will be like really cool for like both enabling better, cleaner, nicer migrations for D2 upstream and also for our internal needs. But yeah, in general, it feels like in the long term, having compilers a library for that kind of stuff would be kind of pretty much a necessity if you want to make any real big changes, because any sort of like partial semantic analysis changes are simply like not reliable enough to just show it to people and say, okay, you can run this tool and be 100% confident it kind of your code will work good after upgrade. So there is sort of concern about that. But yeah, kind of, I totally believe that this is the way to go with any sort of like changes in the language and library. And the way I see it, at some point we probably should just have defix releases that match language releases and package those like simply together with a compiler with the instruction like run this to upgrade all your code. And one more slide, you can probably guess what we'll see here. This one. So the semantic labs are still hiring and hiring pretty much all the developers they can get. And so if you're interested, kind of please contact us, ask questions. And well, also ask questions to me right now. That's it.
I guess this is more of a comment than a question. I used to track DND Git head all the time for all my work. And so then I got sort of a first glance at all the things that were going to break everything. And I tested other people's libraries, and I'd make loads of pull requests to people to fix things. And it really became apparent that a lot more disruption was being caused by bug fixes than was being caused by actual language changes. So there's a sort of contradiction here where we, yeah, as you say, we fix bugs and then don't give people any deprecation path, just go, no, it's broken now. But at the same time, we say, oh no, we can't change that to improve things by some minor amount because even with a deprecation process, it's too disruptive. So I think there is a balance there. I'm just not sure we're quite in the right place.
Yeah, I totally agree. And this is kind of what was mentioned is that we kind of try to be stable in regards of kind of changing and cleaning the language, but at the same time, every single supposedly minor release that has happened, like during last year or two, has broken at least something because of bug fixes. So we haven't really had any truly minor releases. Okay.
This is also more of a comment than a question. This situation affects code.dlang.org quite a lot because how many persons try to compile with the last 3 releases, for example, a package on code.dlang.org? It's very hard to get a package that works on 3 versions, and it hurts, for example, if you want to work on ARM, because if you want to work on ARM, you get to use GDC, which lags behind. And so your package on something is bug fixed is upgraded to 267, for example, but you can't use it anymore with older versions. So that was just my comment.
All right. One more?
I think overall I agree with the sentiment on deprecations, but I think it should be pointed out that in general, we don't really have enough people testing the betas. And a lot of the regressions get out there because code outside of Phobos and D runtime and whatnot is not sufficiently tested, and the test suite doesn't cover everything. People are doing lots of crazy stuff in their own code. So when the beta's out, please pay attention to the beta list, especially the kind of people that are coming to these things, and make sure that your code still compiles and functions appropriately so that if there is a bug in it, it can be reported and fixed before the next DMD release, and so that hopefully we have fewer regressions that actually make it into the field.